Hello everyone, we are from Group 15 who will be presenting our PBL. These are our group's members. First of all, this experiment aims to synthesize 2,2,5-dimethylphenyl acetonitrile from 2,5-dimethyl chloride and to evaluate the effectiveness of nucleophilic substitution under controlled conditions by determining the boiling point and percentage yield of the purified product. The cyanide ion acts as a strong nucleophile and displaces the halide leaving group, triacetone, as the solvent to enhance the nucleophilicity of the cyanide ion while minimizing solvation effects. Sodium iodide as a catalyst to facilitate halide exchange, improving the overall rate of substitution by forming a more reactive alkyl iodide intermediate in situ. So, the question is, what is our problem statement? Our problem statement would be how to safely handle sodium cyanide as the major hazard in this experiment.
First of all, we should know what is the major chemical hazard rating by using NFPA diagnosis system. There is 4 colors using to rate those chemicals, which is red stands for flammability, yellow for reactivity, blue for health, and the last one is white, which is for a special warnings. By looking at this table, we can compare the different chemicals and understand their risk. This table helps us to know how to handle each chemical safely.
Okay, now I will talk about the major chemical hazards in this experiment. First of all is sodium cyanide, NaCN. It is extremely toxic and can be fatal if swallowed or inhaled. It also reacts with acid to release poisonous hydrogen cyanide gas. The highest risk is during weighting and transferring process, so it must be handled carefully in a fume hood. Next is 2,5-dimethyl chloride. It is an irritant and can harm us if we breathe it in or if it touches our skin. It may also cause eye irritation, so gloves and goggles are important when we use this chemical. Acetone is highly flammable and has low flash point. Its vapor can easily catch fire near heat or flames, so it must be kept away from hot surface. Lastly, sodium iodide. It is a mild irritant with low toxicity, but it still adds to chemical exposure, so it should be handled properly. Overall, knowing these hazards help us stay safe by using PPE and handling chemicals carefully.
Now for specific safety measure. For sodium cyanide, it should only be handled in a fume hood and it should avoid contact with all acids. Cyanide kit should also be kept nearby. For alkyl halide, it should only be handled in a fume hood, avoid contact with skin, and we should clean spills with absorbent materials. Now for heating under reflux, we should always inspect glassware for cracks before use, and we should heat using a hot plate instead of a direct flame.
Emergency responses: isolation and evacuation. Evacuate immediately. If there is a spill or suspected exposure, leave the area immediately to avoid inhaling hydrogen cyanide. Seek medical assistance. Call campus or hospital emergency services. Time is critical as cyanide acts quickly. Next is firefighting. Acetone is extremely flammable with a low flash point. Carbon dioxide or dry powder extinguisher. This removes oxygen or interrupt the chemical reaction without spreading the fire. Don't use water. It can spread the fire as acetone is less dense than water. Next is chemical spill. Sodium cyanide must be kept away from acidic substance all times. Labs have spills kit with inert absorbents for organic solvents. For cyanide, there may be special absorbents that neutralize it, like sodium hypochlorite.
That's all from us. Thank you for the attention.